All right, we're going to get started. So, hello, my name is Etienne Caron. I also work for a company called Shopify. I'm from the Montreal office, not the Toronto office, so, and a different province, completely different. So I personally work on the mobile foundation team at Shopify. So the reason I'm here today is that Shopify is very keen on encouraging the personal growth of their employees, right? That's a good thing. I should mention these things because I also want to say thanks for them to allow me to be here today and share a little bit of my passions with you, which have not much to do, admittedly, with e-commerce today. We're going to be talking about little robot cars. All right, so I'm also part of the Google Developer Expert Network, also mentioned because I have to say thanks because their great support actually helps with going to conferences and everything. Google's obviously very invested in the Android community, so thank you for your continued support. Right. Subject I'm here to talk about mainly is IoT and AR, two things I'm really interested in. So we're going to look at how I built this little Android robot car. It's a shared project, so hopefully you'll be checking out how to do that and following in my footsteps. Now, we're also going to learn how to control it from an AR application. At this stage, you might be wondering, why do you work on this stuff if you're actually working in e-commerce? What's your interest into that? Well, big thing is it's kind of cool, right? A lot of us do stuff by passion, but there is a bit more context to it. So a couple years ago, I joined something called Osmos Academy. It's a nonprofit that was founded by good friends in our community in Montreal. I met originally the team, Osmos team, while attending something called WearHacks. So WearHacks, as you might guess from the name, it's a wearable technology hackathon. So at that hackathon, I started experimenting with various wearables to try and see how you can use them as input devices for VR. That was my specific focus that first year. So back then, we were talking about Google Cardboard, just trying crazy ideas. That interest in wearables and VR carried over when we started Osmos. So Osmos, the general idea behind it is to teach social-minded volunteers about emerging technology. So my role at Osmos is to try and put various workshops together. The idea is to attract and educate volunteers by teaching them cool stuff, right? Because that's the first thing. You get into the door because you have an interest, and then you just keep working on it. And for the good of the community, but also for something that you actually enjoy the hell out of, or the heck, sorry. So our core approach for the last few years at Osmos has been to put toolboxes together for different workshops. So a lot of the volunteers that we get are actually not techies. They're usually pretty good, though, at prototyping stuff from working building blocks. Like we've done stuff with AR, with the old Tango tablets. We've had a lot of interesting experiments where a lot of folks had no background in programming whatsoever would start coming up with projects that were kind of mind-blowing and super interesting. Anyway, so the goal here with this project was to build a robotics toolbox, which is still a bit of a work in progress. So getting a robot frame. Well, to get robot frames, little story. I'm talking about one of my favorite electronics websites on the internet. So I like this website because that's how I got introduced to electronics. So we're talking here about ladyada.net. That's the original site that she ran. 2005, I saw this photo on the different blogs out there for that bike wheel with the biohazard lit up sign. That really captured my imagination. Talked with a friend of mine at work back then who had a lot of experience in electronics, and with his help, we then took a little experimental board we had lying about the office and turned it into our own version over the course of 30 minutes during lunch hour. That blew my mind. I was like, wait, you can actually do things that quick with electronics? This is crazy. So that really got me interested in the hobby. Like, it was starting to take off. Things were getting easier. As a kid, I had tried to do some electronics in high school. It was a lot of work. Nowadays, all the tutorials out there and all the parts that you can get, it's a lot easier and a lot more fun. So Adafruit is the official online store of Lady Ada, aka Lemur Fried. So she's here on the cover of Wired, like pretty impressive person in the field. I really enjoy her work. And this site is really a good place to start if you want to do your own electronics projects and you had no previous exposure to this stuff. So when I started the project of making that toolbox, I bought myself the Mini Rover chassis that you can see there. and the Raspberry Pi DC motor hat. So these two items basically are enough to create any robotics project. As you can see, they're pretty cheap. Like you wind up with something functional for under $50. But a week after ordering these parts, I realized I had not done enough research. So a good developer is typically a bit lazy, right? If somebody's already done the work, why do it again? So while looking for the Android Things driver for my new motor hat, I discovered this site, who I just learned is somebody from the area. This is the Android Robocar project. It's a treasure trove of information. I really recommend you check it out. I personally fell in love with the hardware setup. The little red robot rover from Lady Ada was kind of cool, but it had a few shortcomings, which I'll talk about at the end of the talk. But anyway, so that project uses the same motor hat, thus why I found it, because I wanted looking for those drivers. So I stuck with that. What's interesting about this hat is that if you ever want to do a robotics project, you can stack them. You can stack them to control multiple driver motors, DC motors, or steppers, which are useful for other types of projects, so that's kind of nice. They also have a little prototyping area at the back, so if you want to start doing electronics straight on the board for whatever reason you can start doing that without necessarily investing in creating your own little printed boards and doing a business with an online service that does that. So that's kind of interesting. Like the Robocar project, I also decided to go with the IMX7D. That's basically because the platform is Android Things. So you might be asking yourself, if you know about these things, you might have heard that the Raspberry Pi works for Android Things as well, so why not use that? It's a bit cheaper, I think. The thing is with the IMX7 is the USB port that you can use for both power and to run ADB on it. The Raspberry Pi does not support that, so the mini or the micro or mini USB on the Raspberry Pi is only for power. So if you want to connect to it and use ADB, you need to do this over Wi-Fi. And if you need to debug it, the Raspberry Pi that is, you need to connect a serial console to your USB ports, and it's a bit of a hassle. So this is highly recommended if you're going to invest a little bit of time in these kind of projects. The $10 difference or whatever it is probably worth it. This is actually worth mentioning. This is the black box that I get a lot of questions about on the little car. So that's just power. This is actually a really awesome little piece of power. It has two ports, two USB ports. It can power the car pretty much all day if it's not running around. So that's interesting. And if you need it for travel for your phones, it's also pretty epic. This is really my big discovery with the Robocar project was this Junior Runt Rover platform. So what's fun about this is that a lot of space and a lot of mount points for different sensors you might want to use. The frame being plastic has the advantage over the previous frame I tried, which was metal, of not short-circuiting your boards. So that's also a pretty big feature. This is what the unassembled kit looks like. One of the nice feature of this kit is these two parts right there. So they, once you put it all together, they allow you to clip on the Raspberry Pi or the MX7 straight onto the platform in the car, and it stays there nice and snug, it doesn't move. That's a nice feature. Then there's a question of sensors. So for the hardware for a car, you want a few sensors. You can put a ton of things on these devices. There's a lot of choice, so it's easy to get overwhelmed. I just picked two things to start with. So these things have had existing Android Things support when I started out. So that was sort of my reason to pick them quickly. Simple camera, and next to it is an ultrasonic rangefinder. That sensor uses echolocation, so it can tell you approximately how far your car is from a wall, for example. Now, something to mention is that there is somewhat of a small problem with the Android Things platform right now, which is eventually going to be fixed, I believe. Whereas if you use parts like that one that are more for the Arduino world, and thus for real-time type electronic circuits, you're going to get a hard time. You're not going to get really great readings out of these things. So that's something I found out while experimenting with this car, and something to keep in mind. All right, so at this point, slight issue. With all this hardware, I had a lot of components I want to secure down on the car. One big battery, Wi-Fi antenna, camera, ultrasonic sensor. So since this was for experiments and workshops, you might be thinking, oh, it's okay, we'll just use rubber bands and glue. But actually, no, that's kind of the opposite. If you want a toolbox, you don't want it to be all rickety and kind of useless. So was there a way of improving on this? I wanted something solid and cheap if I could possibly find it. So what I went for is 3D printed mount plates. Takes a bit more work up front, but I was very, very happy with the results. So let's look at what the workflow looks like if ever you make your own little car and you want to build your own mount plates. The first thing that you want to go and get is Autodesk Fusion 360. There's other choices out there. You can also use, I'm blanking out on the other names, but there's at least Blender you could use to do this, and the other 3D editor that Google bought that they sold back that I cannot remember the name for the life of me right now. It'll come back. Anyway, so you can use this Autodesk Fusion 360. Mainly the nice point is that it's free. It's a lot more sophisticated than the other software at actually making CAD type plans. So we'll see that in a sec. Yeah, and it's pretty easy to use. Then you take the exported files from this, which are Stl files, for those who might not know. But these are files that gives commands to the printers on how to move the print heads and extrude the plastic. You dump these files into something called Cura, which is typically used for almost all the printers out there. And that's what's going to control the printer, or at least send the files over and make sure that the print job gets started and is managed. I have a picture of a very cheap 3D printer that I own, which I recommend for people who want to get into the hobby and not pay a fortune. That one is $200 last time I checked. And it's, yeah, so that's a pretty good little printer to get, and I highly recommend it. All right. So how do you design 3D printed parts? First step for me was to sit down and start measuring. It's actually worth spending a bit of time there just to sort of get it into your head what it is you're going to actually build. I find that's actually the hardest part, just to figure out what this thing needs to look like, where the wires are going to go through, how are you going to make sure not to step over another piece of the car as ensemble. So that's the part that I recommend people sort of slow down and take their time. So the idea is not to get perfect measures, but you want to have the idea where everything's going to fit. Perfect measures, you can start looking at those when you start looking at Fusion 360. So it is definitely a scary tool at first, but I had never worked with CAD software before heading into Fusion 360. And just to sort of put the point across that it's not a hard thing to use, I'm actually going to do a live demo right now of how you can use it. The longest part is probably going to be me throwing this image, the Fusion 360 software onto the main screen. So please bear with me while I set up my mirroring. Gosh. Wait, where is this? Yeah, I knew it. All right, we're almost there. Why is it not showing me that? That's so funny. Okay, anyway. Well, that's an interesting problem. Maybe this is what's going on. Well, then, okay. I'll try for real for another second. I'm sorry about this. Why am I not seeing my mirroring options? What's going on? Oh, gosh. Okay. I'm thinking I'm going to give up on the demo. So as luck would have it, I actually have slides that I don't show usually, but I will actually show them and go through that explanation. Always be prepared. All right, let's see where we're at. Okay. A bit less interesting than the live demo, but you'll get the idea. So you start out with the software by drawing out a 2D technical sketch, so upper left-hand side. The way you work with this, you create really simple geometric shapes. So in this case, we create a rectangle. We put a circle in the middle of it. Now, these editors are parametric because you specify sizes, but you can also specify rules. So if you want to put a circle in the middle of the plate, you specify the diameter of the circle, And then you can also specify what distance it is from the sides of the shape that you're working from. So that's what we're doing as we go through all the steps here. At the end, you get a shape with a hole in it that's precisely where you wanted it. So you take your measures that you took off the part, and you specify that in there. The next step, you go back to perspective mode. It's one click in the app. You select the zone of the 2D sketch that you're interested in, and you give an extrude command for whatever thickness you're interested in getting. So by doing this, we've just successfully designed a 3D model that can be used in a 3D printer. And it's pretty much as fast as you'd imagine it would be to do something like this. The main trick, if you try to learn everything about Fusion 360 tomorrow, go on YouTube. There's a ton of really nice little videos. I learned all the tricks I needed to make this part by basically looking for how to replicate Lego pieces with a 3D printer. So if you search for that in YouTube, you'll end up finding 2 or 3 little tutorials that give you all the tricks that you need to basically become maybe not an expert, but really efficient at using Fusion 360, and that's within an hour. All right, so this was the final result, final printed result. If you don't want to go through all that and you actually want to use the straight exact platform I just showed you, the Stl files are available in the project at GitHub that I put the link to below right there. So you can go in there, look for the 2 Stl files. So there's a holder for the battery and the antenna, and then the first part right there. And those are easily printed. If there's anything I would change about these designs, if you actually print them, is that the plastic used there was not rigid enough, so they tend to shake a little bit. It doesn't really affect the readings, but if you want to be like really proper about it, you might want to increase the thickness on these things. All right, so this is the fully assembled kit in full view because it's obviously a bit too small for you to look at it on the stage. If you're curious, after this, we can look at it together and I can share notes on all the things. All right, so how do we control this robot now? Let's get to the software part. One of the challenges with robotics is self-location. So how does the robot know where it is? One option to pursue here is to try and put everything on board. So bake enough smarts into the robot so that it's going to take its own decisions as to where to go. That's not the approach I'm taking today, mostly because it's already been done much better by the original RoboCar project. So they have really good examples of how to use it, how to do OpenCV line finding. So what this is usually you draw a line on the floor, and with the algorithms of OpenCV, you can track that line and have the car follow it. And they also tried, and I think successfully, I haven't seen this, I was really impressed. They've trained models for the car to drive itself and avoid obstacles. So I'd really like to see that in action. So yeah, that's one thing to look at if you're curious about self-driving approaches. Personally, I was more interested in exploring the smart remote approach. If you've seen anything I've done in talks before, that's because I'm obsessed with VR and AR, mostly. So I decided, hey, I think this would be a really cool type of remote app. So good news nowadays is that there's ARCore. ARCore is really great. I used to give these talks about VR and AR, and there's a lot of math in OpenGL, and even if it's not necessarily the most complicated math, it is still math you haven't used since high school, so you need to get back into it. It's a lot of work. ARCore really makes things simple. I'm really jazzed about this library because I think it's going to help a lot of people come up with really interesting ideas. So for us to use ARCore to control the car, there's still a lot of stuff that needs to happen. So we'll look at that a little bit. My first big idea with this approach was to use, oh, the video, this is odd. I want to show a little bit of the video. This is the augmented, okay. I'm having a lot of technical difficulties today, but that's fine. So what this was not really showing as a video is ARCore basically has one setup where by using pre-encoded markers as this one and the one you can see up here, ARCore is going to detect this in a scene, in a video feed, and it's going to be able to augment the image where that is. So it's basically going to detect this image, and it will tell you where it is in 3D space, and you can add 3D models on top of that. So things to note about this approach is that in the case of planet Earth, for example, here, this is a really easy image to track. And there's reasons for that, and they're mathematical and based on mostly how the image repeats itself. It's not something that you could really deduce like just by looking at something. So Google came up with a little utility that allows you to put a score on an image. So as you can see, the Earth has a score of 100, and that nice little building, because it has too many repeating shapes in it, has a big fat 0. So how do you find out if your images are good enough? You run the utility that you can see there called ARCore image on the command line. You give it images, it's going to report a score back to you. So I used their original image, and sure enough, it got 100%. The other image I used, which I will not actually be showing, but AR demos have used for a long time, something called the Hero AR markers, HIRO, and that got a score of 80. So that sort of made me see, oh, that probably isn't a great image to use there. Anyway, once you've done this, you can build small database files using the same utility that you can load in your app, and then that's what we're going to use and that we're going to load into our app to let ARCore detect these reliably. So you can have, I believe, up to 20 images, it might be more, 20 or 200. 20 sounds like a more reasonable number. Anyway, it doesn't matter. You can have like quite a few images that are mapped in there, and it can be detected. In our case, we only need the one. So the concept is that by using this mark and putting it on the robot, we can physically determine where the robot is from the app. So that's an interesting piece of information, as we'll see in a second. All right. So that's a bit of code to actually load the image database. As you can see, it's fairly simple stuff. I'm not going to go over everything. I'm mostly trying to impress on you the fact that it's not a whole lot of programming that you need to do. So once we've added an AR fragment to our app, AR fragment is the main component of all ARCore experiences. It's a fragment, as you know and love in the Android community. You just add it to your view. You configure it as we just saw, and it's pretty much ready to go. You're going to have to add camera permissions in your manifest, all the usual little song and dance, which I'm not going to go through here today because you can get that on the GitHub. So once you have it, your starting app is going to have the camera active, and the way that we've configured it, it will also show us the planes that it's detecting. So in this image, the little white dots on the carpet are basically showing us where the plane is being detected by ARCore. Right, so when we get close with a physical phone, I'll make a live demo in a few minutes of this, but just to get the picture. So by getting close to the image of the Earth on the robot, ARCore recognizes it, and in this specific case, what I wanted to do is to pop an interface above the car. And then in this setup, I don't know if it's a bit too dark, but we can also see the feed of the camera from the car being displayed in that interface. We can also see that there's a text label, there's a button or two right there. So the interesting thing to note here is that we're really just looking at a regular straight-out layout XML type file. And that's, I think, really the big deal with this new library. The Android developers that are used to use view components in their projects can simply leverage that and use it in AR. There's obviously a few gotchas and a few extra steps you have to take to put these in 3D space. But the listening code is the same. All the same concepts apply as the stuff that you're used to do in a regular application. All you need to do is instantiate these views in a different way. So there is, though, a wrinkle. This technically is all you need to do to instantiate a new view. So in this case, I give it the context, I give it a layout res ID, right? And that's it. But this is a completable feature, and that's a bit different from what we are used to in the Android world, right? When you inflate a view, it's basically done from the main thread. In this case, this has to happen on a background thread. So if you're an RX Java nut, the project in GitHub has a few extension functions to get a single out of these features. Otherwise, I'm not going to explain completable features today. Either you're familiar with them and you don't want to hear about it, or you're not familiar with them and it's 450 and you don't want to hear about it. So next we have the camera feed itself. So how do we set that kind of thing up? I'm a bit short on time, but we'll get through it. So wait, are we short on time? Is it 5 that we're done, I believe? Okay, that's good, thanks. So the camera feed itself, how do you set up the camera feed? So let's skip all the implementation detail of a camera helper. The gory details of starting a camera to API session are not that interesting. Well, they are interesting, but they're covered in so much detail in this specific project, the doorbell, Android Things doorbell project, that I recommend you go look at that. And if you are no longer interested in Java, just like me, and you want to see the Kotlin version of this, then go see my project. That's all I did. I ported what was in there to Kotlin. It's a bit neater, but yeah. Okay, so we haven't actually touched on how the robot connects to the client. As you might have guessed, Wi-Fi was the choice. But it's not always obvious what stack to choose when you want to establish a connection between two devices, right? So nearby is fun. I thought at first, let's use nearby. But the story was a bit unpleasant on Android Things DP7, which is like Developer Preview 7, which was the one I was working with back in March and April. So that story got a lot better on the Developer Preview 8, which I tried to use at the beginning. But then I found out that the Motorhat drivers were not really cooperating anymore in that specific version. So after struggling for easily a week or two, I decided to just try to write my own socket client server code. Again, we're not going through that today. It was actually very simple, and it's sometimes a bit of a funny thing how just going back to the basics can actually give you a result when trying to use an API that does everything for you would take you a lot of time. The big concepts to remember if you explore the code, which are the things I just wanted to touch briefly on, are this idea that when the robot communicates with the remote control, it is doing so as a client towards a server, and that's what you're going to see in the code for network sockets. Those two signals right there, basically all I'm saying by this is that you're sending telemetry over and somebody's accepting it. On the other side of things, when the remote control is sending commands to the robot, it has to act as a client towards its server. So there's this sort of bidirectional thing going on in the code if ever you look at it. That's the main thing to remember. All right. At this stage, we have a controller app. Our robot can speak to the controller app through Wi-Fi. That's cool. Limitations for development is that if you need to have your robot and your controller speak, they need to be on the same Wi-Fi, right? And the other problem is that if you need to install APKs on the robot, and in this case, the robot's moving around, right? So you're not going to keep it connected to your laptop at all times. So you cannot use ADB over the wire as you would at the beginning of a project. So at that stage, you just, pro tip, all I did was use my phone's hotspot, shared the network, connected everybody on that, and just looked at the hardware IPs, the hard-coded IPs, and just used that. It's pretty simple. So if you do use the project, remember to go and play with these IP values. They might change on your setup. All right, so at this stage, we're sort of getting close to the point where I just would like to do a quick demo, and we have 5 minutes, so the timing's pretty good. So just to give the general idea, in case things get chaotic while I try to make this work, knowing where the robot is in space is super important, and why is that? So the tricky part about self-localization for the robot is that in this specific case, even more so, when the robot moves around, it can't assume that if it puts so much spin on the wheels that it will end up, say, 12 inches from where it is right now. There's no such thing. Like, depending on the surface it's rolling on, that will change a lot. So you can't predict where you're going to end up. So you need some sort of other way to sort of know what's going to happen. If you do have a steady surface, though, what you can do as a cheat is to sort of basically calibrate how much you can move forward or rotate on a given surface. And so that's what we're going to be doing in the little demo I'm going to show. I'm going to first record the position of the car, get it to go forward for a few seconds. And then once that's done, I'm going to record the end of it through the AR UI that we see here. And that's going to record a delta between the two, giving us an estimate of if I power the motors for 1 second, I will end up here. So we're going to go through that as a thing. I'm going to go straight to the demo. I have a couple more code slides, but nobody cares about that. OK, so I'm just going to jump, and hopefully it's going to be a bit easier to share my phone screen if all goes well. Oh, yeah, give me 1 second. Interesting. All right, let's see if this works out. Demo gods, please don't hate me. Okay. All right, so at the first stage, what you do is you basically, this is ARCore. ARCore is looking for identifiable parts of the carpet to sort of decide where a plane is. So now we have like a nice solid plane. A bit far from the little device. So what I'm going to be doing is I'm going to bring the car closer so you guys can still see what's going on up there. All right. This is the part where the thing flies off the stage, I swear. Okay, so let's see. Bit of a demo fail with this. All right. Second, I'll try something else. All right, so what I'm trying to do is to get the marker to be detected by ARCore, which just happened right now. Now we can see the UI in front of this. So at this stage, I can see folks off of the stage. So the first thing we want to do is to calibrate. So I'm going to be pressing on the calibrate button. Now that's the other interesting part with ARCore. Once I've put my view into my 3D space, if I just click on the calibrate button, it's going to be doing its thing. And sure enough, this is not the right version of the app that's running. Oh my gosh. I'm actually zero surprised. So I'll just show you a little bit what the concept is. So I'll make the car move forward a bit further. So we'll just pretend that the car has moved further along for 2 seconds. I'm rescanning the badge. At this stage, I measure the calibration. And we have a calibration. So from now on, what we would do is tap somewhere we're interested in moving forward to. Now, by doing this, we can see that now I have a distance to marker of 16 centimeters. I have no idea how much that is in inches, I'm sorry. And then what you would do is to give the command to go further. And of course, the car is not moving, but that's fine. You get the idea. All right. The demo gods were angry today. Okay, so a few finishing notes, and I'll let you all go. So 2 slides of code. Nope. Well, the only actual math in this is basically this. I had to write my own distance calculator. So if you've done basic trigonometry, you probably are going like, oh, 3D's not that hard. Hey. All right, live demo was a terrible fail, but that's fine. All right, so things that I've learned through this project. Building a good toolbox takes a lot of time and patience. When first things ran, though, I have to say that I was like ecstatic. And that's the main reason I'd recommend that you try it out too. Even if it is weeks of work to just get a wheel spinning right there, you're going to be like, woo! And I swear to God, awesome feeling. Even if you build off of other people's stuff. And that's also what's interesting. I hope you'll be interested enough to jump on to the GitHub and try to contribute, or at least try to use it and complain. That would also be contribution. I'd love feedback. Things that will be added to this toolbox in due time are things like live video for the car, so that gives a better preview. Right now, they're image per second type things. You can mount stepper motors on the frame and actually have your camera move. So the remote presence idea there is definitely something I'm going for with this project. Mapping out room data in 3D space, that's probably far off. Implication there is that you need to use OpenCV to be able to capture point clouds and sort of make sense of your environment. That's a fairly advanced topic, but could be done. And last one I have prepared is Stereoscopic View, which is not something that's going to work soon because it requires USB camera support on Android things. But we might see that this year with any luck. So that's about it for me. Thank you for your time. The GitHub, again, if you want to take a quick picture and look at the code and share notes with me, you can put feedback on the GitHub issues, and I'll be happy to reply. And with that, I think we're going to call it a day. Thanks again.